This tutorial will cover the creation of combined or stripped footings, and once analyzed, its calculation sheet and detailed drawing. Like isolated footing, the combined footing module is also based on a rigid analysis method. It can design more traditional two-column combined footing or multi-column strip footing. Once all of the supports have been created and the global settings have been established, the next step is to create the combined job. Go to Create a New Job under Job Setup. Here, a job name is required. Remember to specify the job type as combined footing. Then choose which supports will be assigned to the combined job and change other job info if needed. I will create the combined job using only supports 2, 3, 5, and 6. Then choose the load cases which will be used for the combined job's design. Usually these are just the load combinations. Then create job. Now a new set of options become available to create strip footings between supports. Also, the combined footing local settings have become available in the main navigator. Select two or more supports on the geometry view to create a strip footing. A simple way to select supports is to use the top view instead of the orthogonal view. It's important to note that the selected supports for one combined footing have to be collinear and parallel to either the global x or z axis. For obvious reasons, the footing dimension along that collinear axis is called length, and the perpendicular direction is called width. Then click Create from selected nodes. Strip footings can be created on supports that were not included in the combined job info section. These supports will automatically be included in the combined job analysis. I will add pedestals with anchor bolts on supports 5 and 6 to show how they would look in the detailed drawing. The first design parameter for a combined job is concrete and reinforcement, which provides input for basic information such as the concrete unit weight, yield strength of steel, and strength of concrete. It also has minimum and maximum reinforcement options. The user has to specify the minimum and maximum bar spacing, footing bar size, and pedestal bar size to give the user control over this input and to prevent the program from generating too many designs. If set as default is set to yes, whenever a new job of the same type is created, its default concrete and reinforcement settings will be set to the ones currently specified. The set as default setting is used for all design parameters and some global settings as well. Cover, soil, and safety allows the user to enter information relating to cover and soil. If you wish to ignore the depth of the water table, simply enter a very large depth well below the foundation to make it a non-factor. If a certain volume of the foundation is under the water table, then the program will include an uplift force equal to the buoyancy force of the concrete. Enter a surcharge to include an extra pressure load on the soil if needed. The rest of the cover and soil parameters, such as soil bearing capacity, should be self-explanatory. Footing geometry provides two options for specifying combined footing dimensions. One is calculate dimensions and the other is set dimensions. Calculate dimensions requires the user to input a minimum and maximum value for some of the dimension parameters, and the program will calculate the most efficient design between those values. Set dimensions allows the user to set the footing length, width, and thickness. These values should be entered under minimum length, minimum width, and minimum thickness, because the program eliminates the maximum parameters since there can only be one input for set dimensions. Since the dimensions are set, the length and thickness increments aren't needed. If calculate dimension is selected, length increment and thickness increment both specify the increment in which the program increases footing dimension size if they must increase to meet code standards. Length increment controls length and width increment, and thickness increment controls just the thickness. The user can choose to have a fixed or unfixed left overhang, right overhang, and width. The fixed option allows the user to more explicitly define how the combined footing dimensions should increase should more surface area be needed. As you can see in this GA drawing, the left overhang is the distance in which the strip footing extends beyond the leftmost support. The right overhang is the same except on the right side. The Optimize Footing Size Dimension option, if selected, will choose the appropriate overhang direction to increase footing size should an eccentric load exist. For example, if the combined footing dimensions need to be increased due to this moment in the negative z direction, the program will consider compressive and tensile stresses caused by the moment and will increase overhang in the direction of compressive stress, which, in this case, is to increase the right overhang. With sliding and overturning, the user can specify the coefficient of friction, factor of safety against sliding, and the factor of safety against overturning. Click Design to design the isolated foundation using the current global and local settings. If these settings are changed, the job must be redesigned to take into account the changes. Once designed, the calculation sheet, GA drawing, and detail and schedule drawings become available. The calculation sheet specifies how each footing was designed. It includes detailed steps, figures, and references to the code which was used for design. This section gives a detailed account of the pedestal design calculations. If any pedestal is present, the program will automatically design a pedestal with biaxial moment. The detailed drawing gives GA plan, and elevation views for individual footings. This drawing shows support and footing dimensions and any reinforcement. If there are pedestals or anchor bolts, their drawings are shown. The detailed drawing can be exported to CAD software such as MicroStation or AutoCAD using the Save Drawing As feature. Another feature I would like to mention is the global settings in the Home ribbon. Under Top Reinforcement Settings, the user has the option to either always calculate top reinforcement based on concrete and soil weight, even if no uplift is present, or to calculate the top reinforcement only when the foundation is subjected to uplift forces. If applicable, a self-weight factor for top reinforcement can be applied. Under Concrete Check Self-Weight Settings, the user can either neglect footing self-weight for concrete check, consider net pressure for concrete checks, or consider footing self-weight for concrete checks. The last option is only applicable to isolated footings. Of the three options, considering net pressure for concrete checks is the most common. Also, either the gross bearing capacity input or net bearing capacity input can be chosen. This option controls the bearing capacity type of the inputted value in the soil design parameters for all jobs. With reinforcement placement option, the reinforcement in the X and Z directions can be toggled between the top and bottom. For more information on these options, please refer to the context sensitive in the Help menu. Thank you for watching.